For RCR TV, I'm Sean Kinney, and welcome to HetNet Happenings, where we take a look at all things DAS, Wi-Fi, small cell, and much more. Welcome back to HetNet Happenings. I'm excited about this episode. It's a subject area that I'm personally very interested in, and that's smart cities. I like smart cities because it takes virtually everything we cover at RCR Wireless News. I'm talking access networks, metro fiber, the Internet of Things, autonomous driving, and more, and it combines it all into one thing, a smart city that could potentially change the quality of life for millions of people all at once. Last week we showed you a lot of the chipset work from the Consumer Electronics Show that's going into enabling IoT applications, particularly in the industrial space. This week we're going to go back to the Consumer Electronics Show to talk to our friends from Ericsson about smart cities and some of the attendant solutions. Ericsson refers to this as the connected industry and society in their programming. To get an understanding of what that means, let's hear from Ericsson's head of Connected Industries, Alejandro Ferrer, to get a high-level overview of the company's strategy around this.
Yeah, when it comes to connected cities, what we do is we approach a very top-down approach. So we look to the high-level problems related to competitiveness of the cities, problems related to efficiency, problems related to safety, and problems related to resilience. We don't have solutions for all of them, but once we know the priorities, we can focus on some specific cases where we have developed technology, we have developed solutions. So for example, when we talk on competitiveness, what are we doing? We are entering in the area of logistics. We are entering in the area of monitoring the cargo that moves from the ships into the ports and then into the transport of the city. So what we do is we can monitor the location, we can monitor the status, and by doing that, we can introduce efficiencies in how the cargo is moved in the city. When it comes, another example is what we are doing in the transport area. So if we can provide connectivity, for example, in the metros, in the commuting trains, in the buses, the people that is traveling in these transports can continue producing while they are commuting every day. That's more than 1 hour in cities like Sao Paulo or in other big metropolis. So it's a lot of hours that can be used for producing for the city. If we look to another area, for example, the efficiency. What can we do for efficiency? So in Sweden, for example, we are working in a neighborhood in Stockholm. It's a little bit of noise. So we are working in a neighborhood that they expect that 30% of the energy has to produce locally in that neighborhood. So what type of grids or smart grids are needed? What type of smart meters and what type of information has to flood from the grid into the smartphones of the people? We know that already that more than 2/3 of the people in the cities want to know more about or monitor more about what they are spending or how they are using the resources in the cities. And this also applies with transport. We see more and more the people using multimodal transport in the cities. So if I want to go from point A to point B, I may decide the transport I'm going to use based on many reasons, based on cost or based on the time I should be on destination, or based on experience I want to have. If I want to have, for example, good connectivity during the whole transport. So, but what is more important is I need to have information. What are the alternatives from going to point A to point B? What is the easy way to pay or purchase tickets for bicycles, for connected motorbikes, for buses, for metros? I'm going to switch here from one way to another. I'm going to use a car sharing. So all this enhance the way that people use efficiently the transport that is in the city. We know, for example, that in London they cannot grow the number of ground transport. So what they have to use in much better way the vehicles that they have and the streets and the streets that they have. They are not going to build more under tunnels, or they cannot handle more vehicles. So what can they do? In the area of resilience, so there are many cities that they have challenges like earthquakes or big typhoons. So how information of these critical events can reach easily the population and those recommendations. So we are working, for example, with sensors that detect these critical situations and initiate a civil warning process. So how we can send alerts massively to the devices of the people, so they know that now there is a typhoon. It's time to you to find shelter. So those type of solutions should be easily to deploy and will enrich a lot with the capability of interconnecting agencies like firefighters, police, ambulances. So all these agencies have to be coordinated with an emergency control center that can collect information from sensors that are in the city, from devices of the people, and can exchange that information. So, for example, we had done a work in Australia with Telstra that we were simulating how to coordinate all these agencies in case of big fires that are happening in Australia every year. In case of Brazil, in San Jose dos Campos, we have a control center that is using information from traffic cameras in order to quickly react against events. It could be traffic events or security events. So the big security risks have been dropped more than 20% under the last year, just because information is available and is shared between traffic and police authorities in San Jose dos Campos. And what we see basically is that when we are able to collect the information, when we are able to process the information in a efficient way, when we are able to share this information between authorities, between utilities, between logistic companies, is when the smart city becomes a reality. It's not one thing, smart city. It's a group of cases, a group of scenarios that we can attack or we can improve, that will make the traffic better, cities more safety, and more convenient at the end for the citizen. That is what we are looking. And again, it may be differ from city to city. One city maybe have some more challenges with the competitiveness, and the other one with more challenge with the resilience. So the way in Ericsson we approach to it is we have a very consultative approach, dialogue approach with the authority before we start putting things on the table, because the priorities are different in all the cases.
Now that we have an idea of how connected industry and society can positively benefit individuals and enterprises, let's look at some potential solutions. Alejandro mentioned smart meters, so let's start there. In this clip, Sean Kinney, who's Director of M2M and IoT Solutions, demonstrates the company's smart metering.
Hi, I'm Sean Kinney. We're here at CES 2016 in the Ericsson booth. I'm a Director of M2M and IoT Solutions, and we're here to talk about the things that we're doing within industry and society. We're going to be looking at our smart metering as a service solution that we're providing to utility companies that we just launched this week at CES. And we've been working a lot in the utility space for quite a number of years, and we're bringing that back into a packaged solution to make it easier to go to market. And it's really going to be about bringing an end-to-end solution, everything from the connectivity management, the service enablement components to actually pull that data in, manipulate the data, manage the data, validate the data, managing the devices and the gateways to get the data into the network, and then finally actually monetizing it, because monetization, of course, is why we're all in business here, and bring that up the stack. So I'm going to start over here in the corner Here we've got a smart meter, and we're agnostic to the meters that we use. We don't actually make meters at Ericsson, but we work with any of the providers out there and integrate those in. This particular meter we've got connected in through one of our smart grid nodes as acting as a gateway, and that's what's providing the cellular connectivity to get that data back into the network. From there, we're actually able to manage that connectivity with our DCP, our device connection platform. So that means for every device that's connected to the network, we know how it's provisioned in the network, how it's connected, what types of services, whether it has data services, LTE, and so forth, and we can manage that entire life cycle of that SIM from start to finish, ordering new SIMs, getting them into the devices, managing the connectivity, turning them on and off as needed, and doing any troubleshooting straight from a web interface. It makes it very easy to connect those devices. From there, we actually have physical gateways that we use. So you can see one of the gateways right here, and we have different form factors, and this allows connecting in different types of grid assets. So everything like the smart meter that we just talked about, to a relay, a base station, power quality management, and getting all of that information back into the network. And for all of these, we have all the tools in the back end to manage them. So if you pan to my left here, you'll see actually the management console where we actually can see physically where these devices and relays are located. You can get a visual cue as to their status in the network, and you can actually drill down into some of the information and the configuration on these devices. So here we're actually showing some of the power quality management for one of the gateways that's actually live out in the field today. So if we swing back around then and move up the stack a bit, let's focus in on the actual services that you're going to get if you were actually an end user. And this is where the consumer aspect comes into play. So monetization, of course, is key. So the first thing with all of this is being able to get the data back from all of these homes back into the network. So you can imagine all of these connected back, maybe through a gateway at a central location near the neighborhood, coming back into a hosting facility, for example, and we validate all that data. We operate on that data so you can now start to do more interesting things. So instead of just taking a monthly meter reading, you can actually start to do things like time of day pricing. You can start to deal with other scenarios, free weekends, and really take that data and manipulate it in a much more sophisticated way and bring that all back into the utility, of course. From there, you've got to be able to manage the end-to-end. So before you can even get doing the data, you've got to bring those orders online. So it's really important that you have an easy to manage order system. So order to cash. So here you can imagine somebody new moving into a neighborhood. They want to have a smart thermostat in their smart home. So in they go, they order their utility services, and they say, you know what, I want to have a smart home, I want to have a smart meter and a smart service. So they go ahead and order that. That goes into the back end service order center, gets fulfilled. From there, the thermostat itself gets picked up in the warehouse, the order's dispatched internally, and then that goes out into the field. So then the field tech has all the information he needs at his fingertips to be able to deploy that. The testing is done all automated through the network now because it's provided as service, and we can close out that order. So now we know that the customer's online, we can pull that data back in. Now inevitably something's going to go wrong. You're going to have a fault somewhere in the network, but the key here is being able to quickly find that, troubleshoot it, and solve that. And so again, just like we did for the orders, you want to be able to automate that. So we've detected a problem in the network. We can again dispatch that. So now we have our home. So now we pick a resource, a field tech to go out and do that. He'll again get something on his device, his field services device. He'll find the problem. He'll resolve it. We'll perform those network tests, automatically determine that it's resolved, close out that case, and the end user's back in service. So the key here is that all of this then moves in. Then we have flexible billing solutions on top of all of this. So we have our MetroNet platform geared towards enterprise billing. When you think about IoT types of services, whether it's utilities, transportation, connected anything, you often have a complicated value chain. So, you know, it's B2B in most cases, B2B to C, B2B to B2C, multiple partners. So being able to do settlement across those partners, being able to have different relationships in there is very critical. So our MetroNet solution is actually very key to these types of solutions to be able to monetize this, give everybody the access that they need to the data from a billing perspective, and then actually be able to pull all of that together in an end-to-end billing scenario. So really it's all about providing that end-to-end. Connectivity management, service enablement, device management, and then of course monetization to the end user and fulfilling that end-to-end service. So that's how we're going about it when we talk about smart metering as a service. It's really about providing an easy end-to-end user experience and package for all the players in the value chain.
So that's smart metering. Now let's move over to a connected water solution that's geared towards sustainability. We're going to learn more from Charles Dasher, an Atlanta-based technology design lead.
All right, so I'm Charles Dasher. I'm a technology design lead for Ericsson. I work out of Atlanta, Georgia, in a little part of the company that we call the Atlanta Idea Factory. So what we've done is we've created a thing that we call connected water. For Ericsson, sustainability is so important. We have entire initiatives, for example, our Technology for Good initiative, or the work we do with the UN, or our work with refugees, or dropping cellular networks in when we have earthquakes in places like Nepal. So it's really important for us. At our core, we really have this sense of being green. And of course, we also have a vision for 2020, which is the network society. We believe that everything is going to be connected, and we are the ICT connectivity partner that we hope everyone's going to work with. So when you're talking about environmental monitoring and environmental sustainability, there are really only one category of device on the market at the moment, and those are industrialized devices that are made for water, municipal water systems, or for governmental agencies, and so they're very expensive. In Atlanta, Georgia, there is a river called the Chattahoochee River. It runs from the mountains of the north all the way down to the Gulf of Mexico through Alabama and Florida. And this is the source drinking water for 4 million Atlantans, so it's a pretty important body of water. It's monitored by an organization called the Chattahoochee Riverkeeper, which is an environmental advocacy organization. They've been around for 25 years. 25 years ago, the Chattahoochee was one of the most polluted rivers in the country. Now it's one of the cleanest because of the work of these people. Unfortunately though, the tools they have are those industrial tools, so they're really expensive. For example, to test water, they actually get on a boat with one of these $10,000 devices and they go up the river 3 days a week, checking 70 sites. Put it in the water, take it out. Put it in the water, take it out. Or they rely on the community to bag water samples and bring them to their office. So they approached Ericsson to say, what can you do to make this better? So the first thing we did was, we said, what do the sensors do? And they do a number of quality of water measurements. Conductivity, which is how much stuff's in the water, like how many salts and things like that. Turbidity, which is how clear the water is. Think a bottle of water versus hot cocoa. Temperature we use in calculations, as well as fluorometry, which is the detection of the fluorescence of a substance like laundry detergent, which is a great indicator of E. coli, because when you have a sewer spill, there's almost always toilet paper and laundry detergent. So what we've done is we've taken a $10,000 device and we've shrunk the cost down to almost under $300, including connectivity, and we've connected it using LTE Category 1 power saving mode, which is a very new thing. It's part of the standard, but Ericsson's one of the first companies to deploy this. And this allows us to have an increased amount of sampling in terms of how often during the day do we take samples, but more importantly, it increases our battery life by years and years and years. So it's a really great thing for us. Currently in Atlanta, we actually have some of our sensors deployed in Proctor Creek, which is an urban creek in Atlanta, and urban creeks are vitally important as part of the ecology. These creeks can sometimes have school children playing in them, other times they're filled with tires and debris. So our sensor is in there, making sure it's clean, and that's actually done with your cooperation with AT&T, who is our connectivity partner in Atlanta. So if you like, I can show you this demo here, which is actually, so currently right now in our tank, we have clean water, and we're going to introduce a sewage spill. Now, sewage spill, we're actually going to put dirty water in there. And by dirty water that actually has laundry detergent in it. It actually smells nice, it's pretty clean water, but for a river, it's dirty. Our fluorometer is going to actually fluoresce the optical brightness that are in the water, and we're going to read it, and we'll be able to detect that there is a sewer spill. And so we can alert the community, we can then do big data analysis, we can start building what we call a river signature, which is really a trending data over one or many sensors, so we can really kind of get a hold of, what's the river really like, when is something bad, when is it not bad, and that's what we're doing with connected water.
To my wit, smart cities are still in their infancy, but we're going to see a long-term global movement towards urbanization that's been very well documented by organizations like the UN. What this means is that at some point cities are going to have to get smarter and get connected to the residents, otherwise they're going to be totally unusable. As this picks up, let's go back to hear from Alejandro again about what he's expecting the big 2016 trends to be in the smart city space.
So we see three major trends. I mean, urbanization is growing. So we are now in 50% of the population concentrates in the cities, and by 2015 we are talking about 70%. So that's a big trend, and that means that all the resources of the city have to be optimized. The second big trend is that specifically about the resources. I mean, for example, we see that by 2030 there will be almost 2 billion people living in cities where water restrictions. And we say water, but we could say energy, or we could say another major resource. So how we help for the people to be more efficient and all these resources to be used more efficient. And the third big trend is about traffic. So we are talking about 2 billion cars coming again by 2030. So how we handle all this amount of cars, of vehicles, how we move, transition to more multimodal type of transport in the city, and multimodal transport is the big, I would say, one of the big trends in transport for people in the city nowadays. So that's a reality happening already in some of the major cities.
All right, folks. Well, thanks for joining me to learn more about the work Ericsson is doing in regards to connected industry and society. These clips were filmed at CES, and we've got a lot more content from that show up on the RCR Wireless News YouTube channel if you'd like to see more from our trip to Las Vegas. Next week, we're going to take you out to the AT&T Drive studio in Atlanta. Then I think we've got a show coming up after that on concealment solutions for small cell and outdoor DAS deployments. Then we're going to head over to Barcelona for Mobile World Congress, so be sure to tune in every Friday for HetNet Happenings. For RCR TV, I'm Sean Kinney. See you next week.
HetNet Happenings is a production of RCR TV. To reach Sean Kinney or to suggest a show topic for HetNet Happenings, you can reach Sean at skinney@rcrwireless.com. On Twitter at Sean Kinney RCR. To find out more about the latest in HetNet and all things wireless, dig into rcrwireless.com.